face right now. Sorry, it's hard to tell. The camera is facing the other way. I'm gonna quickly resend this link. It seems like it didn't work. Go to the new link right here. Um, Sounds good. Hopefully you guys are on right now. Let me double check here on my other computer. Again, apologies about that issue. You can still see my tripod here. Um, I will start. I'll start with the economics. If you're not there, oh my god. Well, that was my mistake pressing the cancel button when I meant to press the pause. I don't think there actually is a pause on this YouTube live stream. Still learning now and then. I hopefully the link sent. Okay. Oh yeah, there's some more people on there. Okay, so I am going to get started with the exam. Right now, I'm going to start with economics, and then I'm going to go over to physics. We're going to do some questions. I'll explain everything for you so you can get a good feel and a better understanding for your test tomorrow and on Friday. So, let's start off here with economics. So, the first question on the review exam, the review test I made right here. See if I still have it up. First question. The second question is, what is economics? So when we talk about economics, the main thing we are looking at is studying how people interact with each other. In most cases, it has to do with how people buy, how people sell, money related with that type of stuff, as well as government interventions, how people think, and specifically what they do with the available resources they have. So that's a quick definition of economics. Um, it helps you give a good idea of what you will be studying in this course, as well as multiple questions, as well as long as you know that the root foundation of everything is based on people's choices. So that's economics. Second point here is scarcity, which basically means that we want everything. I mean, you probably want a lot of things, but if we all wanted a lot of things, the world just wouldn't be able to supply our needs. So that's the idea of scarcity, that we have an infinite amount of wants, and we want absolutely everything. We want the money, the houses, all the cars, just everything. However, the world, based on its limited supplies, doesn't have that. So we have this situation of scarcity where you unfortunately can't get everything, or at least the entire world can't get everything that they want. So that's the idea of scarcity. Next is opportunity cost. Basically, this is the concept of when you make a choice, there's always something good that comes out of it and something bad or something unintended that comes out of it. That's just the idea of opportunity cost. It happens a lot when you're dealing with price floors and price ceilings, as well as many monetary policies. There really is no right way or wrong way to deal with something, as the effect will always be a negative one and a positive one. So that's the idea of opportunity cost. Something very, very simple, as long as you understand that economics is the way, the study of people's choices, as well as scarcity and opportunity cost ties in well with that. So if we look down here, everything we see in our world is made using the factors of production. That includes land, labor, and capital, as well as one more called entrepreneurship. These three or four things make up basically everything you see around us. Nothing can be created without land, labor, or capital. If you don't have a place where you can make something, it's not going to be made. If you don't have people making something, it's not going to be made. If you don't have the money to buy the materials needed to make that, it's not going to be made. So that's the idea of economic sorry, of the factors of production, and the economic questions as well ties into that. When people ask, what should we make, how should we make it, and for who should we make it? So types of economies. This is this is probably one of the simplest things in the entire unit. I'm going to give you a quick rundown right now. Number one, demand economy. Basically, the government controls everything. That would be a complete command economy. The government controls every policy, every market, absolutely everything, all the trade, all the exports, all the imports, the spending, the investment, just everything. That's demand economy. Market economy is the exact opposite. The people determine the market, determine the prices, determine everything around us. And mixed economy is somewhere in the middle. Yeah, that's pretty simple stuff. Um, let's see. If you have your booklet out, do download this, print it out right now, and we can start filling them out. We've already covered question 2 and 3, where economics is the study of choices, and 3 basic economics questions is for who to produce, how to produce, and what to produce. And demand, if we move on here, when we start to get into microeconomics, we start to study. Tchaikovsky saying, my mic is broken. I am sorry, I can't fix that right now. Let me check. Apologies about that. I actually can't fix it right now. I'm just using a normal iPhone here, because I don't really have any advanced streaming equipment, and you can see the tripod right here. Um, yeah. So if you do experience some very high pitch noises, just turn down the volume, and you should be good to go. Okay, so a market is basically where buyers and sellers make an interaction. Sellers give a product, goods or services, to buyers, and then buyers in return give them give them money, and then that money is used in a cycle, which we will explain in which I will explain in the macroeconomics, which is called the open circle cycle, which explains where goods and services come from, as well as income and money. So when we look at these types of markets, they can easily be explained using this simple demand and supply graph. Demand is basically the quantity of how much people want of a good or service. Very, very simple. It's downward sloping, because as price lowers, more people want to buy that specific product. For example, if you've ever been to a sale, 25% off, that sale most likely motivated you to buy the product if compared to if it wasn't on sale. So that basically drives the quantity down here, which means how much how much people want to buy. That's simply demand. Demand shifts if by non-price determinants, basically what people think or people want or people order will shift the demand curve either to the right or to the left based on multiple different determinants. Um, if you go to the Quizlet, there is a Quizlet explaining Quizlet to help you learn all of these non-price determinants. Very, very simple to do. Just play through it a few times on the Quizlet, and you'll memorize all of these. I memorized it in on the plane ride, so in 20 hours. It's not that hard. Just do it on the bus. Do it to the car to school. Do it to the car back, and do it to the car to school on your economics exam. Simply go through all this on the Quizlet, and it'll be memorized. You have to memorize this. I repeat, you have to memorize these non-determinants of demand because there will be a question that asks you demand curve shifts as well as supply curve shifts. I'll just briefly go through them. However, they are very, very simple. Okay, I'll move this here to the side, to the other side. So, the first is change in taste and preferences. Simply, if people want to buy something specific based on like needs or society or what just people want, that's a change in taste and preferences. If they like certain things, that would shift the demand curve to the right. If people start disliking things, it'll shift the demand curve to the left. An example would be fidget spinners. People just wanted them because of memes and social media, and it blew up. So that shifted the demand. That caused the demand to shift to the right, and it was caused again by changing taste preferences. The second one is the number of buyers, basically the people who will buy the object. If there's more people who are going to buy it, there's a higher demand for the good or service. Very, very simple. Changes in income. This is primarily affected by GDP growth. And basically, if there's more rich people or more people get more money in this case, they are going to buy more expensive goods. This can be classified as a normal good or an inferior good. A normal good would just be a good that people with normal levels of income would buy. Inferior would be the exact opposite. People with low levels of income would buy. For example, let's say there was a Great Recession or something. It caused everyone's income to just plummet. More people would buy noodles. More people would buy noodles. Oh shoot, no one hearing what I'm saying. Kennedy, what are you doing here? Anyways, more people would buy noodles instead of high quality steak, for example. Nothing inferior, that's normal good. I see some people are complaining about the mic. Again, I'm sorry, I can't fix that. It's my phone. There's nothing I can do. Sorry, man. Okay, moving on. Changes in price of related goods. I do not know how to get the man's attention. I see you right there, Kyle. You have my attention right now. So if you say something, I'll probably read it. It says your message was rejected, retracted. I don't know what that means, but again, if it's a mic problem, I can't fix that. Sorry, man. So, changes in prices of related goods. These are basically goods that are related to the good that has the demand curve right now. Um, for example, substitute goods are goods that go together. Sorry, substitute goods are goods that satisfy similar needs, such as Coke and Pepsi. If the demand of Coke decreases for another non-price determinant, then the demand of Pepsi would increase. That is because they're basically the same thing. And don't argue with me, Pepsi fans. But a complement good would be a good that is used together, such as milk and cereal, or ink and printer ink and printers. So if the demand of one increases, the demand of the other will also increase. So supply is the amount of a good that sellers are able to produce and produce. In this case, we would say are able to produce and supply, right? The amount of goods that sellers are willing to sell and give, right? So that's just the supply upwards curve because since firms want more profit, if they can sell the good at a higher price, meaning they're not necessarily making more profit, but in this example, they would be. If they were to make more profit at a higher price, they want to sell more of the goods. So they order more goods because they're going to make more profits. Again, a shift in the supply curve is caused by a non-price determinant, as the ones I'm about to state. If the supply shifts to the right, it means that the supply increases. If it shifts to the left, it decreases. Here are the non-price determinants of supply. Very, very simple. Again, use the Quizlet to memorize this. Changes in cost factors of production. Basically, a supply shock, meaning that if something was to destroy the factors of production or make it extremely hard and rare to get this stuff, the price um, would increase for whatever good is being supplied right here. An indirect tax or subsidy, basically the government would pay people not to buy this or would pay the firm to make more of it. That would shift the supply curve. Um, Changes in numbers of firms and market. If there's more people supplying a specific thing, um, that would also shift the supply curve. Changes in technology. If there's better equipment to make a certain good, it's going to be made a lot faster, and there's going to be more of it. Changes in expectations. Basically, if Farmer Joe thinks that it's going to be rainy in the next month, or if there's going to be a thunderstorm, he's probably not going to plant his crops because they're all going to get wrecked. So that's going to shift the supply curve to the left as there is no crops being supplied. Changes in prices of related goods, joint and competitive. Joint supply is basically when one factor of production makes two distinct goods. So if you were to increase the amount of factors of production, you'd make more of the two goods. For example, cows, if you make more cows, then you're going to make more milk and beef. That's very simple. Joint supply. Competitive supply is basically, for example, Farmer Joe, if he has an area of 100 square meters to make crops, let's say corn has is selling more, there's a higher demand for it compared to another crop like soybeans, he would make more corn, and that would shift the supply curve as well. So the best place to be with the supply and demand curve is at the market equilibrium, mainly because the price people want to pay is the same as the quantity suppliers want to produce. So that market equilibrium makes it for the best deal for both people, um, and both buyers and producers are happy. Um, okay, we are at 20 minutes right now, I believe. Let me double check. Yeah, we're around 17 minutes. So I'm planning on quickly finishing up microeconomics right now. Consumer surplus is basically the benefit that people, that consumers get with a certain good, um, service that they buy. Specifically, if they buy a good that they're willing to pay for a lower price, they get a benefit, meaning that if they were to buy a movie for $10, if they want the movie so bad, such as Avengers: Infinity War Part Two, if they want that movie so bad, they're willing to pay what, like $100 for it, and it just sells for 10. Then that's consumer surplus. That's the benefit that they're getting from buying it. Producer surplus is the exact same thing, except for producers. If they want to sell something for a good at a higher price than they make it, that difference is called the producer surplus. And social surplus is basically both the producer and consumer surplus, just their surplus in general, minus the deadweight loss, which is the amount wasted. I'll get into that right now. So if you look at this graph right here, hopefully you can see it. Consumer surplus is up here, and producer surplus is down here. Um, doesn't really much to explain. It's quite straightforward. This area right here is what consumers are willing to pay for the device for whatever product you're selling. Consumers here are willing to pay a lot of money. They have higher demand for this product compared to consumers down here. And consumers who would have been down here do not buy the device because they don't see the value in buying this good or service. Um, Indirect taxes are taxes. Um, sorry, are taxes on spending to buy particular goods and services paid indirectly by the government, uh, to the government by the seller. Why government put indirect tax? Basically, it is when, let's say, we have cigarettes and we want less people to smoke, we would put an indirect tax onto the good, meaning that the price of the good would increase and the government would get more money. Why do we want this? Number one, it's taxes for the government, so it gives the government money or revenue. And number two, it's basically to prevent a bunch of harmful products that governments don't want. So it just reduces that number completely. Market outcomes with an indirect tax. Basically, if the government imposes a tax onto a market or a specific product, the supply curve would shift to the left as the um, as firms are willing to supply less of a good as they're being taxed on. Remember, an indirect tax or an indirect tax in this case is taxed towards the consumers and the producers. It's not only towards the consumer, unless the graph was completely inelastic. However, that is, you don't have to know that. But basically, this area right here, that's how big the tax is. And most of the time, the tax is split right in half. Sometimes it's more towards the consumer. Sometimes it's more towards the producer, based on how steep the demand and supply curve is. If this demand curve was steeper, then more money would be taxed towards the consumer as there is a higher um, demand in this specific case. That is not always the case, but in this graph right here, that would be the case. That's simply taxes. And subsidies is when the government pays consumers or producers to do a specific thing. They just give money to them if they do more of it. This normally encourages firms to make more of a specific product. So, for example, electric cars, if the government was to impose a subsidy on Tesla, for example, they would be making more electric cars. And that's kind of what the government wants, as it encourages consumers to buy more of a specific good. It increases subsidies can increase firms' revenue. They can support specific industries. For example, if the government likes the electric car industry, it can just keep on throwing money into it to make it bigger. It can, and as well as encourage the consumption of a specific good. Again, the subsidy shifts the supply curve to the right, and this area right here, which should be parallel, that's the big supply. That's the subsidy given right now. So price controls are basically when the government change wants to change the diagram to satisfy a specific need. The two most famous price controls are price ceilings and price floors. Price ceilings is when the government, let me pull up a better picture here, is when the government adds a maximum price of a good. The price ceiling is always below the equilibrium. It's kind of confusing. You normally think of a ceiling going above, but it's below, as the price cannot go over a specific height. And a price floor is the exact opposite. If they don't want a price to go below a specific height, back to the market equilibrium, that is above the equilibrium. That is above, and it normally creates a shortage, meaning that there firms are making more of a specific product than people are willing to buy. That's called the quantity demanded and the quantity supplied. If the quantity demanded is higher, in this case the price floor, then there would be a bunch of goods that nobody wants to buy. So remember, if a price ceiling is placed above equilibrium, it has no effect, as people will want to buy products here in the equilibrium. And the same thing is true if a price floor is placed under the equilibrium, it will also have no effect. So why exactly do governments put price floors and price ceilings? So a price ceiling is mainly to support a price ceiling is mainly to reduce the price of a specific good or service in this case. So it helps the consumers as the consumer surplus grows, so more people are willing to buy the product, and it does not help the producers. Um, is my mic actually broken? Like I'm reading the comments right here. Can you guys not hear a single thing I'm saying? Comment down below if you can hear what I'm saying right now. I just want to know if this works because let me just double check one second. Let me double check. Can you guys hear me right now? Holy crap. So, what I have right now is. Oh, crap, man. One sec. So, what I can see right now is that there's some really, really annoying sound. Yeah, killed your ears. Yeah, I can even hear it right now. Like on this one right here. I'm sorry. Let me just double check. I'll just add something in. Problem with my mic. I am using my iPhone mic. My iPhone's mic, and I do not know how to fix it. Again, really, I really do apologize for this. I hope you can see on the comments what's going on here. Let me see if it's again. Let's see if this works. Okay, can you guys hear me right now? Let me see what's happening here. Let's see. Oh. Yo, can you guys hear me right now? Let's check this out. Can you guys hear me? I believe I know what the issue is with that. So, can you guys hear me right now? Okay, it works. Okay, let me have this in. It works. I'm back, people. Okay, so let's continue on with what we were working on right now. Okay, so it now works. Let's where were we here? So let me check. Okay, so we were explaining the consequences of price ceilings for stakeholders here. Basically, stakeholders being consumers, producers, the government, and society. Those are the four stakeholders that we have in microeconomics right now. If we were to describe the price ceilings, if a price ceiling is added to a market like this, what happens is actually quite interesting in my opinion. What happens is that what happens is that so if a price floor is added, what happens is that it creates a surplus again, where the quantity supplied is much bigger than the quantity demanded in this case right here. What then happens is that the consumer surplus grows so much smaller as the price of the product firms are selling increases, which basically means that consumers who wanted to buy the product at the equilibrium price now cannot anymore. So their desire and their lust, in this case the consumer surplus, has decreased to this small triangle right here. On the other hand, the producers, since they're selling the product at a larger price, are benefiting more from this. So they make more of the products, which creates this surplus. However, since their producer surplus is so much bigger, they just want to keep on making more products because it will make them more money. So what you're left with here is a mystery triangle right here, which is the quantity demanded. Basically, this area right here is goods that no one has bought. So what ends up happening is that this area right here basically gets deleted, gets forgotten. The government has to buy it up, or else it'll be destroyed basically. And the governments don't want that, of course, so they buy up this area right here. It's called the dead weight loss. Basically, goods and services that are just lost like that because no one wants them. The consequences of for the economy here is that the firms become more inefficient as the dead weight loss increases. It's just a loss in general for society as there's some dead weight loss as the consumer surplus has increased. However, the only gain would be that the producer surplus has also increased. So that's kind of why they do price floors to help the producer specifically. Um, Minimum wage is a very dominant example of these price floors. Basically, where if we were to have the supply of labor or the people and the demand for employees, in this case, the demand curve would be the businesses and the supply would be the workers. This price floor, also known as the minimum wage, would be the minimum price that you'd have to pay a worker to work. So what ends up happening is that the demand for workers decreases as the consumer surplus would decrease. So less businesses want to buy, I guess, hire workers at this as at this wage, so the amount of workers decreases. And as you can see, it creates a surplus, which means that there's more people who want to work, but not enough jobs, which unfortunately creates unemployment. Um, Again, these are a few consequences of minimum wage. The most important one here would be the misallocation of resources in the labor market. Basically, a bunch of people who want to work but don't work, so that kind of brings down, I guess you can say, the potential of the power. However, the only good side is that the people who are working are being paid more right now than they normally would at a minimum wage. So it kind of benefits them, but it doesn't benefit anyone else here. And if we go to, so that is microeconomics. Since we had some noise glitches, I am just gonna speed run through the beginning to make sure you guys are well aware of what's happening. So, introduction to economics. What is economics? It is very simple, very simply the study of people's choices. What people want, what should they do with given resources and factors of production. That's economics. Scarcity is the idea that there are so many things that we want. I mean, if you're anything like me, you want everything, right? You probably do as well. You probably want a car, a house. I don't know what else you want. A bunch of phones, a bunch of Nintendo Switches. I don't know what you want, but basically, what we want is infinite. But since the world is a finite place, we don't have enough goods and resources to supply that. That's the idea of scarcity. Basically, meaning that everyone wants everything, but there just isn't everything. The next is opportunity cost, which is the value derived from certain policies and certain actions. Basically, everything you do as a positive action as well as a negative action. And when it comes to economics, you have to find the best choice between the both, as many monetary policies always, although they might seem good, they always do have a downfall. Three basic economic questions: what to produce, how to produce it, and for who to produce. Basically, just outlining the economy in general. Very, very, very handy, especially if you're a business. You answer these questions, and you can be well on your way to multiple different markets, industries. Type of economies, there's just two really: command and market. Command is when all markets are controlled by the government, and market economy is the exact opposite. All markets are controlled by the people, and I have to say, market economy is much, much, much better, as most as the equilibrium on the graph is where people benefit the most and where producers benefit the most. So on a market economy, everything we see around us would be at the equilibrium. There would be no price floors, no price ceilings, no taxes, no nothing, which means that both the producers and the consumers are um, are getting their best and their more preferred choice instead of the government controlling specific rules. That's the type of economies. Demand is basically how much people want a specific thing, and supply is how much firms are willing to give a specific thing. Very, very simple. The law of demand states that the reason why we have a downward slope here is because people like things that are cheaper, so they buy more. That's quantity, that's price. So if you've ever gone to like a retail shop and there's a sale, like 25% off, you're more likely to buy that than something that isn't on sale, as you can see a higher benefit to that, and that's called the consumer surplus, and that is why the demand is sloped downwards. Um, so what shifts the demand curve, meaning what changes the price and the quantity, is caused by non-price determinants of demand, such as tastes and preferences, tastes in the number of buyers buying these things, changes in income, and changes in prices of related goods. Simply use the quiz that I send you, you'll be able to memorize that like that, and you'll be good to go. When it comes to supply, supply is basically, I guess you can say, the demand for producers. Um, if people, if producers sell a good at a higher price, It basically means, in this case, it means that they're making more money to themselves, so they want to make more goods as it'll make them more money. People are really selfish. So that's the reason why the supply curve is upwards. A shift in the supply curve, again, increases or decreases supply, is caused by non-price determinants. So a shift to the right would be an increase in supply. A shift to the left would be a decrease in supply. The non-price determinants of supply are a little bit longer, but basically the same thing. Except from a producer's point of view. I'm not going to go through this. I already did, and I want to get to physics because it's a lot better, in my opinion. But I still find this pretty fascinating. Memorize this in the Quizlet, and you'll be good to go. So why exactly is market equilibrium very important? Basically, it's the place where producers and consumers are both happy with each other. They are willing to pay a price that producers are willing to supply, and every market naturally adjusts to this, as people will not buy goods and services that are too highly priced, and suppliers won't sell things that are too low price compared to what they make it. So markets naturally adjust as long as there is no government intervention, such as price floors and price ceilings. That is microeconomics. Quite simple. Now I'm going to go into macroeconomics. Macroeconomics is basically the study of how the government improves the economy, I guess you could say. The first most important thing of this unit, I have to argue, is called the circular flow model. It basically states how money and how goods and services are produced in society. Here we have the consumers and firms, or the producers. If I get a closer look here, actually I'll use this one right now. So it's actually very, very simple if you look at this graph. The one Mr. Carson gave us is actually really confusing. I found this one to be a lot easier to understand. Basically, people buy things, also known as goods and services. So firms give them goods and services when people give them money. Really easy to understand. Producers then pay people to work. Again, this is the factors of production: land, labor, capital. Labor is probably the biggest one, most important here, as well as capital. So firms pay people to work. That work then makes things and services that people then pay. Very, very simple concept. Just memorize this and you'll be good to go with that question. Then, however, since this is the model I just showed you was a closed circular flow model, which means that money doesn't leave the system unless your government does not accept trade, and it's not really a government, basically living on an island. That is impossible. There's always going to be something called injections and leakages into the economy, where money, I guess you could say, is gained and lost. Here's another diagram basically stating the injections that come into the economy, circles through this, and then sometimes they might leak out. As you can hopefully see by this diagram, if the injections, stuff we put into the economy, is bigger, then you have an economy that grows. If the leakages is bigger than the injections, then you start to get an economy that is losing money and resources. That is very, very simple to do. So when it comes to this, circular flow diagram, hopefully you can see me right now. When it comes to this circular flow diagram, you can basically measure the GDP, also known as the gross domain product. That can be calculated in many ways, but the simplest way to calculate it is simply measure the income earned in this country, and the GDP is basically the value of all final goods, services, as well as income in our country. in 1 year. So if the GDP of a country is higher, it means that it is producing more goods and services as well as more income for the people, and it's the main factor of economic growth when it comes to studying economics. There's a small difference between real GDP and nominal GDP. Real GDP means GDP adjusted for inflation. Inflation is when prices start to increase in percentage over the years. It's not that the goods themselves are getting more expensive, it's that the value of the currency um, is basically getting worthless as the years go on. Very simple to understand. Real GDP is without that, so it's used to calculate the GDP in past years, such as the 1950s, 1980s, and nominal GDP is the GDP not adjusted for inflation. It's very, very, very rarely used in economics. However, it's an important term to know. Another way to measure GDP is by using GDP per capita, which is how much, um, basically how much GDP every single person used. So if there's a massive, absolutely massive country, it's very difficult to compare that big country to a very small country. For example, if I have something like China and I compare it to another a small country such as Djibouti or something, China has a massive GDP and Djibouti has just a fraction of that. So what we would use is we would get the GDP and we would divide it by the amount of people that live in these countries, and then we'll have a very good indicator to see which country has a higher GDP. That is GDP per capita, and it's very useful to compare things. So Amin says, does gross domain product relate to range? Does gross domain product relate to range? Sorry, Amin, I am not sure what range means. If you can specify in the comments, I might be able to answer your question. Yeah, if you're seeing this right now, just reply. I'll answer it in just a sec. So there's a few ways to measure GDP. There is the income approach, where you just get the income of the circular flow model. Very simple. Or you can get the total spending of all final goods and services within a year. You use this formula right here, C plus I plus G plus X minus M. This part right here is probably the most important, the G minus X minus M. Basically, C, consumer spending, plus investment spending, plus government spending, times exports minus imports. If we go back to our document right here, we see that if we have higher imports, right here in the M, if we have higher imports, the economy is, or the GDP is actually decreasing, and if we have higher exports, the GDP is increasing. So I didn't actually talk about this. So what are the injections and leakages? Again, injections grow the economy. It's money that enters the circular flow model, and leakages is money that leaves. It's very, very simple to understand. Basically, imports. I'm going to get into this later, but it's called a trade deficit when your imports is bigger than your exports. Basically, the reason why if I import something, my GDP decreases, the number one reason why that happens is because I have to pay. Let's say I was the US and I was importing stuff from Canada, or if I was importing stuff from China, I'd have to pay a few things. Number one, I'd have to pay the tariff, and number two, I'd have to pay the shipping. So if I import something, I am losing revenue in that process. Sometimes it might be a lot cheaper to buy things from other countries, but for the most part, this import spending really does reduce the revenue of specific countries, and countries can just start increasing the tariff, and that'll actually make them more money. And on the contrary, for exports, if I'm exporting something to another country, that country has to pay me for the tariffs and probably the shipping as well. That's why it increases, and that's why it leakages. Sometimes I get confused why like imports doesn't add things into the economy. Well, it doesn't. That's the reason why. Savings is basically money that I guess you can say is left, and due to
interest rates and stuff like that, this value starts increasing and nothing really happens, so it's kind of just lost because it's just set apart and not talked about. Um, hey, Janik. No, sorry if you're confused right now. I'm currently in grade 10 right now. Oh yeah, I believe you're a subscriber, right? So I believe I saw you on the Get Productive Alpha. No, this is nothing to do with the company. This is a live stream I am doing to prepare for my physics and economics exams, which I have in the next 2 days. You're welcome to watch this. This is grade 10 stuff. I'm not sure if you're quite interested, but you seem really interested right now. Yeah, so I hope you understand. Okay, moving on. Um, Investment spending, again, that increases the money spending because people are putting money and then getting it back, and government spending as well add money into the cycle, and taxes takes money away because it's subtracting the income that people could be earning and using it for the government. That is these injections and leakages. And yeah, Janik, I honestly really do like helping people reach their personal best, which is what I try to do here on Ace to Be Labs. And I'm making this live stream right now to help people prepare for their exams. So, moving on. So we did GDP per capita, evaluating the use of national income statistics. So GDP doesn't necessarily tell us how good of a life we're living, because as economists, we don't really care about that type of stuff. People are just a medium, I guess, to improve the economic goals and help them really just keep the economy growing, I guess. So we don't really care that much as economists about um, what people's likes are like. So when it comes to GDP, it doesn't take into consideration these things. Um, Not only the quality of life, but as well as money sold in like the black market and the underground economy, secret stuff, the deep web, right? Yeah, GDP does not take into account that. It only takes into account legal services and transactions, as well as it doesn't really take into account laundry money as well. That's just money that's lost and not claimed. However, it does not take into account these things. Uh, you can probably read them over there. I'm not really going to explain them that much. There probably will be a question about this on the exam. I strongly recommend you just memorize 3 of them and be able to explain them. The easiest, in my opinion, that are to memorize is just include goods that are not sold in the underground economy, as well as improvements in quality of goods. It doesn't measure how good a quality is. So the GDP in, let's say, 1950 is quite different as the one now, as TVs have become significantly cheaper and of better quality. So it's kind of hard to compare both of those elements. So that's one right here, as well as environmental damage, destruction of natural resources. This can significantly affect the supply, as well as supply shock and the factors of productions being used right here. This is one thing you want to take into account, as well as the standard of living factors. So if the people are getting unhappy and they're just not becoming happier, GDP does not care. Does not care at all. So then we come across this subject right here called the business cycle. Very, 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 very simple to see. So simple, actually. Here we have the real GDP, meaning how much the gross domain product we have. And here we just have time years. So what's kind of interesting about this is that we can actually measure when an economy is going to boom and when it's going to hit a recession. And I find this honestly one of the most interesting parts of economics. So here is the long-term growth trend, which is how much economies could be making based on their real GDP. So for example, economy or country X could be making um, GDP of $100 billion. However, this green curve says how much it's actually making. So it could be making 100 billion based on the real GDP right here. But based on these other factors, it is not. It's actually fluctuating. The real GDP is fluctuating, goes up and down, up and down, up and down. And what causes these shifts is actually really, really fascinating. So there's a few vocabulary you have to learn. Contraction is when the GDP hits a recession. This is when the basically income for people and the GDP just goes down. That's called a trough. Then the expansion and the peak. So this area right here is the booming ages, such as the 1920s or 1955, or as well as the late 80s. So this is up here in the U.S. economy, and the trough is the recession, such as the Great Depression and the 2008 recession right here. Um, yeah. So what causes this to go up is um, it's basically when people see that prices are increasing, they want to buy more and invest more money, so the GDP increases, causing higher rates of inflation. And then when that kind of reaches a tip, like no one can really invest anymore because it's just going down, the GDP will start to decrease. And down here, this is really the only thing you have to remember with this. In the peaks, there's really high inflation, and in the troughs, there is high unemployment. For example, right now, Canada, if you were to draw this out, it would be around here in the expansion area because employment rates are pretty high right now. There's lots of people who want employees to come and work for them, as well as the inflation rate is at a pretty constant rate. I believe at around 3%. Um, so that's the business curve. There are ways to control this, such as monetary and fiscal policy, and we'll talk about that. However, before I jump into that, there's something really, really, really important, and I feel like this is the beating heart of macroeconomics. It's basically the goals of the government, what the government wants for its economy and its people. Number one, and the thing I've been talking about for the last few minutes, is GDP growth. Governments want a high GDP because, like, who doesn't want a lot of money? That's the number one goal. Number two is low unemployment. The main reason why is because if you have less people working, your GDP normally would fall, mainly because there's less people that are producing and the productivity of the country is pretty low. So that's low unemployment. Economic growth is increase in GDP and stable inflation. Governments don't want deflation and they don't want high rates of inflation, as the economy can easily get out of control and the GDP would just plummet. High levels of income inequality, they want people to be equal because it just makes a happier country in general, as well as no trade deficit, which would decrease the GDP. So this goal right here is strongly strongly correlated to the economic growth. So if we were to scroll down a little bit, so when I say unemployment, you probably think of a guy sitting on his couch playing Fortnite instead of going outside and actually doing work. That is actually not what unemployment is. That is called hidden unemployment. Unemployment is the state when someone is looking, constantly looking for a job, and they can't find one. That is unemployment. People that are looking, reading books, going to the internet, searching up things, and they just can't find a job. That is unemployment. It is not some guy drinking soda on the doing nothing all day. That no. Unless he's not working for unless he's not looking for a job, it is not unemployment. And that's one of the big issues when measuring unemployment in general. You can't really take into account the people that are not looking for jobs because you just can't measure that in general. So that's called hidden unemployment right here. And it's one of the difficulties in measuring unemployment. One of the main problems is that, number one, it doesn't include hidden unemployment. It also doesn't include people who don't want to work, such as discouraged workers, and people who are working right now that just don't want to work. It doesn't take that into account. It also doesn't take into account the underground economy, the black market, sketchy stuff like that. Doesn't take that into account. And it also doesn't consider the inequality between races and how specific racial things can actually decrease their motivation in some instances, as well as their probability of getting jobs. So that's one of the difficulties in measuring this entire unemployment concept right here. So obviously the consequences of unemployment are pretty straightforward. I mean, it just stands out right when you see it. It's the loss of real output. The government is being inefficient. It's also the loss of a bunch of it's the loss of income for the GDP. It's also the loss. Firms basically have less people to work with. Um, Sorry, that's what I already said. So it increases crime rates, it increases stress levels, increases homelessness, and it also decreases the potential tax revenue that people could be earning, as well as industries and firms. So again, inflation, prices percentage increase. Deflation is when they decrease. Consumer price index. Great. So this is really quite fascinating, as most things are to me. Um, this is how we measure inflation, the inflation rate in different in lots of different countries. Because if I was to buy, for example, a backpack, that's the first thing that popped to my mind. If I was to buy a backpack here in 2015, I'd have to pay what, like $40, something like that. If I was to buy a backpack back in 1920, I'd only have to pay like, I don't even know, like half a buck, $1, something like that. So how to measure this is basically you get the basket year, which is when you get an index base number, basically just a solid number that explains the prices in base, and then you start analyzing the increased percentage of the value of a specific good over years. For example, if I had a base of 100 in 2002, as I have right here, and if I had a base of 100 in 1982, in 2016, if that number is 240, it means that inflation increased 140%. And if the base was 100 in 2005, then in 2016 the inflation rate would be 80, 90%, or a bit less, but you probably get the idea hopefully by now. There's a few reasons why this might be inaccurate. The biggest one right here is the quality of products may improve. A really, as I said before, a really expensive TV that is not that good does not take into consideration a really good TV that is now being sold for very little price. So that can really affect the CPI and make it less accurate, as the base year and the percentage of increase for this specific good can throw economists off because of their improved quality. You can go ahead and memorize these. I personally haven't completely memorized all four of these, but the main reason why is just the demand of these, the supply of these, the quality, as well as the demand, that people don't change their preferences, that they change their likes. It can also be income and stuff like that. So go ahead, memorize this, and you'll be good to go. So why is high inflation a very bad thing? As you can probably imagine, people lose their savings. That's the main cause. As well as governments don't really know where the GDP is going if we have a high inflation rate, as it starts to get out of control. It can also increase inequality, as people now have to work harder for basically the same thing as long as the prices adjust. And that's basically it. Economic growth, role of productivity, investment in human capital. Okay, physical capital. Very simple. Physical capital are things you can buy. Human capital are people. So very, very simple thing. If I invest in physical capitals, I'm investing in more of these, as well as an improved quality. If I'm investing in human capital, I improve the quality of the labor force, such as the health, the knowledge, and the skills of these workers. So those are two different investments that governments can make, as well as firms and consumers. So a few consequences of economic growth. Yeah, we can talk about this. And the Lorenz curve. This is, again, another interesting concept. basically this graph right here, this line is line of perfect inequality, and it's very simple. This is the income, the percentage of income the money makes, and this is the percentage of the population. So, hopefully you can see it. What this basically says is that if this line was completely straight, then if I get 50% of the population, pluck it right here, they would own 50% of the income in a country. Of course, there is no such thing as a country with perfect equality. Most curves look like a banana, this curved shape. So if around, for example, here at point B, 40% of the population would own 15% of the income, and if I was to move it up to here, for example, 80% of the population would own around 60% of the income. And this line most of the time gets steeper as you go up, as all these billionaires right here own a large chunk of the income compared to other people. So a way to measure this is using something called the Gini coefficient. Another formula where you can get a numerical value and compare it to other countries to see how equal they are compared to you. For example, this area right here is A, this area right here is B. So the formula is A plus B divided by A. That should give you a number from 0 to 1. The closer the number is to 1, the more unequal the country is. For example, the most unequal country in history was Brazil in the 1980s. It was at around a 0.8. And if we were to draw that out in a curve, it would basically be a flat line and then just a huge spike, which would mean that around 50% of the population would only own less than 10% of all the income in the country, which is a really big problem, as there is a lot of poverty if the Gini coefficient turns out being a number close to 1. And of course, there's a lot of problems with poverty, such as bad living standards, drugs, and other addictions. There's higher mortality level, as well as you start to get a decrease in productivity for a country as you're investing less into humans. The balance of trade. Okay, so this is probably, I believe we are done. Yeah, so I went through the entire thing. I just want to go through this right here. This is the most important thing in economics relating to the circular flow model. It's basically the balance of trade. I explained it already. It's where if you have more exports compared to imports, your GDP will increase. That's mainly because if you're exporting something to another country, governments are gaining more revenue from that. And on the contrary, if you're importing something, you're going to have to pay tariffs, which is like a tax, and the government spends more money on shipping and stuff like that. So there's a lot of consequences, higher interest rate, there's more pressure, there is the GDP growth starts to decrease, and this causes surpluses and deficits. What most countries want is a surplus, which is when there's more exports over imports. So since you guys are watching in Canada, you have to buy those Canadian objects because it ultimately helps the economy compared to imported China stuff, such as this Nintendo Switch right here. So there's multiple ways to reduce the trade deficit. This is the most important, basically contraction, monetary, and fiscal policies. What that does is if we go back here to our business curve, right here, what this would do is it would decrease the recession, decreasing unemployment, and in turn that would also increase the export. So that's what a fiscal policy does. A monetary policy is when you increase the investments, and that in some cases that would also reduce the trade deficit, almost always actually. There's also an expansion monetary policy, which if we go back here again, is a policy that is aimed to mainly decrease inflation, because ultimately if this peak goes super high, it's really good, but it's also really bad because the real GDP growth does increase, but you also get higher levels of inflation. So what these policies do is they change the government, so they change specific policies, so this starts to decrease. That is about it. I was gonna say one more thing though. If I decrease, 1 second. Something very important actually. Fiscal policy. Yeah. So the main problem with these policies, though, the consequence, I guess we could say, is that it does decrease the recession. However, most of the time, what that ends up doing is it makes the next recession even bigger, and as well as the peaks, it makes the inflation rate even higher by simply contracting the recession. That's one problem with monetary and fiscal policies, but they do have a really high benefit with reducing trade deficits. So that's it for economics. I did make this question booklet right here. There are a few people online. I would strongly recommend you do these questions. It does help. I'm quickly going to go through them right now. Okay, so explain the following terms. Consumer surplus, how much consumers are willing to buy something. Economics, the study of people's choices. 3 basics economics question, what to produce, how to produce, for whom to produce. Demand is how much people want and how much people are willing to pay for a specific good or service. And allocative efficiency is when you make specific people with higher skill, I guess you could say, do things that they are more talented or more skillful in. For example, you wouldn't make a chef, or I don't. You wouldn't make. What's a good example? You wouldn't make a chef, unless he's a very talented chef. In this case, go out and do these economics. And on the contrary, if some economics guy knows nothing about cooking, you wouldn't make him cook because that's just inefficient. The chef is much better at cooking, and the economics guy is much better at analyzing the economy. So that's allocative efficiency when people are more productive and when goods are, I guess, put to their best use. So which of the following non-price determinants shift the demand curve? With these questions, some of these shift the supply curve. They are all non-price determinants except for this one right here, except for change in price. Change in price does not shift the demand curve. It only moves among the demand curve. Yeah, it won't shift it. Only non-price determinants shift the curve. So changes in taste and preferences, that would shift the demand curve as more people don't want or want to buy a specific thing. Changes in income, people can buy a specific thing, that will change the demand. Expectation, that will change both supply and demand curve. If people expect specific things to happen, they would buy things accordingly. Changes in price, that would shift. That would shift that wouldn't shift anything exactly. Change the technology, that would shift the supply curve. Joint goods, those are two goods being produced from one thing, such as a cow. Cow makes beef and milk, so that would be joint goods. That would be a supply change. Changes in the numbers of buyers in market, that would be a demand shift as there's more people in the market that want to buy a product. Inferior goods, those are things such as noodles. Those are things that people would buy with less income, such as noodles. Substitute goods, those are goods that can easily be exchanged, such as Coca-Cola and Pepsi. If more people want Coke, less people are going to want Pepsi. So that shifts the demand curve. Changes in tax, as we talked about before, that would shift the supply curve. Okay, draw a diagram showing a subsidy given to people who buy an electric car. If we have a supply diagram, I can't write on my TV. We have a supply diagram. The supply curve would shift to the right as producers and consumers are being paid money to buy electric cars in this case. Explain why governments add indirect taxes. They add indirect taxes to number one, give them revenue, and number two, either reduce the consumption of a certain good, as people don't want to buy things if they're more expensive. So, also one more important thing to note with this is that taxes affect the consumers and the producers, meaning that a tax doesn't only make producers pay more money, it also makes consumers pay more money. So, next question, if quantity supplied is larger than the quantity demanded, this causes there's more of one thing than there are people who want to buy it. This causes a surplus, as there is more of one object and not that many people want to buy it. That's the answer to that question. So the government imposes a price floor to help farmers make more money. Draw the appropriate graph and show who benefits. Very simple. You draw the x, you draw the demand and supply, draw a price floor in the middle. What would happen is that the consumer surplus would decrease, the producer surplus would increase. It would also have an increase in deadweight loss, as there's a whole bunch of things that people don't want to buy, but producers still made because they thought they would make more money off of it, and the government would buy that stuff up. And the reason why they do this is a price floor is to make sure the prices can't go below a certain point. Let's say they wanted to encourage, let's say they wanted to if they wanted to decrease consumption of something like cigarettes, they would add a price floor to make people buy less of one thing, as people don't like buying things that are worth more money. That's the demand. So macroeconomics, explain why an increase in imports over exports creates a trade deficit. I explained this 5 times in this video. Imports, government is paying tariffs and possibly shipping. Exports, government is gaining tariffs because they're exporting to other countries. So that is why it creates a trade deficit. Trade deficit is more exports than imports, which would decrease the GDP. Moving on, outline the 5 government economic growth goals. Number 1, low stable inflation, low unemployment, income equality, economic growth, and the last one, economic growth, low stable. The last one, what was the last one? Why can I not remember this? Let me check. You see, even I sometimes forget this type of stuff. No trade deficit. How did I forget that? Okay. We're back. So, continue on with our questions. So, draw the circular flow diagram. Businesses, households, money goes to households, then people buy stuff from businesses, and in turn businesses give them stuff, goods and services, and people give them labor, capital, and land, I guess. So they work for them and the producers pay them back. So explain why GDP is not an accurate representation of the standards of living. It doesn't take into account it doesn't take into account poor conditions, as well as environmental disasters and destruction. So explain different methods to promote equality. Very, very simple. The government can give money to unequal people or poor people with low income. They can just give them money. That's called a transfer payment. They can also give merit goods for free, such as healthcare, schools, all that type of stuff. They can just give it for free, as well as for free basically. And the other one is the provisional taxes, I believe is the term. I'm not 100% sure, but it's basically when the higher income you earn, the more percentage of a tax you have to pay. So if you're making $1 million, the government can start subtracting that and they'll subtract more from someone who makes $10,000 just to make sure the income and wage gap, the income gap isn't that big. So that reduces inequality. And finally, explain the consequences of these methods. The biggest consequence with transfer payments is that um, it reduces government spending. Why would you give money to these unequal people or low income earner or poor people, whatever you want to call them? Why would you give them money when you can use that money for other things such as improving um, well-being or stuff like that? And the other one is merit goods. Why would you give merit goods for free when you can use that money for other things? Because the government has to pay for this type of stuff. And the other one was provisional taxes, I believe what it's called. Why would you start removing money from these high earners? Why would you do that? And what's the main consequence? The main consequence is that it would probably discourage people and also make them quite angry that you're taking their money away. So, we are done economics. I'm going to take a quick 2 to 3 minute break. My legs are killing me right now. So, we will resume physics in just a few minutes. So stay online. Tell your friends to join. There's 5 people right now. When I first started, there was 10, and then the microphone thing broke. That was my mistake. I did not realize it at the time. I apologize for that. So tell them to come over. Your physics friends, whatever, send them over. I'm gonna take a little break right now. I'll leave this up. Holy crap, I am dying. So dying of power. I will leave this up right here, and I'll take a little break. I'll be back in just a minute. Okay, I am back right now, and I'm ready to go through the entire physics curriculum with you guys. If you haven't done the questions already, please go and do that right now. And throughout this, I'll be answering those questions. Any questions you might have here in the chat. Yeah, Kyle. Lol, that's pretty good. Yeah, I apologize again for the mic. What seems to have been happening was that my phone was connected to my headphones, so it was using the mic from my headphones, which was all the way back there. So I apologize for that. That was my mistake, as most things in your life are. So let's get right into this. So when we look at physics, there's 3 central units that we have. Again, if you're not taking physics right now, I strongly suggest you watch this, as it will help you in the future. The 3 units are, number 1, energy conservation, movement, mass, sorry, not mass, movement, kinetic energy, elastic potential energy, all that type of stuff. That is unit 1 as well as momentum. Unit 2 is radioactivity, atoms that decay, um, atoms that emit atoms that emit neutrons, such as your uranium reactions, all that type of stuff. That's unit 2. Unit 3 is heat and energy transfers. If I heat something up, how much energy, how much will it increase by, and vice versa. So let's get right into it right now. Hopefully you guys can see this. Okay, so very, very simple stuff. Efficiency equals output over input. Or an easier way I found to think of it is it's the useful energy divided by the total energy. So if I'm running a motor and only if I'm running a motor and it's taking up 100 joules of energy and I'm only using 10 of those joules to actually like lift something up, the other 90 joules is wasted. So if I write that into the equation, it would be 10 divided by 100, which is 0.1 or 10%. So it's a very simple formula. Remember it. Remember it any way you want. My way I found helped me a lot. So efficiency of a ball, this stuff, we did a lab on this. So how sure are you? Loss. Okay, this right here, there's a lot of different types of energy. So far I haven't seen this on any test. I doubt it's going to be on this test because number one, it's pretty simple. It's just a few types of energy. Heat, light, um, kinetic, electric, sound, and I keep on forgetting this first S. But that's Schleck, all the types of energies that you can make. Oh yeah, I believe that's spring now that I think about it. So energy is measured in joules, and the law of conservation of mass and energy states that mass and energy can't be created or destroyed. It's only conserved and transferred. And that is perfectly shown in this diagram right here, something called a Sankey diagram. It's one of the easiest things you're going to do in this entire course. If you look right here, this is how much energy, this is how much total energy is being inserted into the system. This is how much energy is being useful energy, and this is the amount of energy that is basically being wasted to useless things that don't have to be used. So that's the Sankey diagram. Very, very simple to use. You have to be very precise when drawing this, or else you're gonna get it wrong. You are. So these little squares right here, that would each represent an area. In this case, it would represent 100 joules based on the question, and you have to draw it very precise with your ruler. So if you don't have a ruler, you should probably bring one. I just use my calculator. That works fine for me. Yeah, so the total energy would go here, energy wasted would go down here as arrows. Again, very simple stuff. Very, very simple stuff. So that's Sankey diagram. Potential energy, okay. So potential energy is P equals mgh. Again, simple. Mass times the gravitational force times the height. So if I lift something up, it gains potential energy. Because if this height is at 0, if it's on the ground, it has 0 potential energy. As 0 times anything is 0. And this potential energy is basically energy that is stored in the object as I lift it up. Because in this case, the energy would be transferred from the movement of my arm to the object right here. So it's stored. If I scroll down a little bit, stuff is very simple to do. Kinetic energy is the energy in movement. Okay, so potential energy is how much energy is stored. Kinetic energy is how much energy there's in movement. Again, if we look at the equation right here, K equals 1/2 of mass times velocity squared. So if an object is at rest, meaning the velocity is at 0, the kinetic energy is also going to be at 0. Again, very simple to understand. If I throw something, it gains kinetic energy, depending on how fast I throw it and how much it weighs. And something else that's quite interesting here is that according to the law of conservation of mass, energy is always conserved. So if I lift something up and then drop it, the energy is going to be the same. When I lift it and the energy takes to move this ball down here, considering it's completely elastic, meaning the kinetic energy is conserved, the energy up here will be the same as the energy moving the ball down. That is this theory right here, that potential energy before is the same as kinetic energy after. Okay, this stuff is simple. Okay, Hooke's law. This is people. I feel like people screw up on this all the time. I especially did when I first started out. But like all things, once you understand what it is, it's actually really, really simple. So what exactly is Hooke's law? You. Oh shoot, my thing is glitching. So here's the equation. Right here. I'll bold it. Oh, no, never mind. I can't actually edit it. So it's elastic potential energy equals half kx squared. Okay, so what the hell does k and x mean? Very, very simple. K is the spring constant. X is the extension. So you probably know what the extension is. If I move a spring 10 meters, I'm extending it 10 meters. That's easy. So what the hell is the spring constant? It's basically how much force it takes to expand a spring 1 meter. So if I have a spring, how much force is needed to move the spring 1 meter? If the spring is really, really stiff, this is going to be a higher number, as it takes more force to expand it 1 meter. Again, force is measured in newtons, so this is newtons over meter. You can use a Newton meter with a Hooke. If I was to expand a spring, that would show me what the spring constant is. Very, very simple to use. You basically plug this number, multiply by the expansion, you square the expansion, multiply by this, divide by 2, and you get the energy in joules. Simple, easy, good. Also, if this makes it any clear, I don't have a graph right here with me, but the spring extension can be displayed on a graph as well. It's basically the same thing as putting force on it and expanding it 1 meter, where down right here is newtons. Sorry, right here is meter and this is newtons. Basically, the graph would be an upward slope. As the more force I put, the larger the spring is going to extend. So that's one way of measuring it, other than actually going up to it and expanding it with a Newton meter. So that's elastic potential energy. And Hooke's law states that elastic potential energy is how much energy is stored in a spring, and Hooke's law states that if I was to expand a spring, it would increase in energy. Yeah. So here's a few questions. Energy change in a pendulum. Very simple. Pendulum moves. It has more potential energy at the highest. And something actually very interesting, since we live in a world where, or if you go anywhere, basically anywhere in the universe, there's matter, everything around us, so that removes a lot of the energy from a substance. For example, if I was to throw a ball, if I was to do the calculations and figure everything out, the ball that I drop is not going to have as much energy as I predicted, mainly because of air drag, and the energy is lost as heat. So if I was to throw a pendulum from my nose right here, was to swing up, it actually wouldn't touch me because energy is lost as heat in the air drag and heat up there in the hinges. So that's something kind of fascinating. Here on the pendulum, A and C have the highest potential energy, while B has the lowest. That's simple. If I have a ball higher, it has more potential energy. If it's lower, it has less. I assume you guys know this stuff. If you have any questions, please use it. So this stuff. Okay, momentum. My least favorite thing in all of physics is momentum because it's annoying. Momentum is defined as how the velocity times mass. That's the definition. It doesn't really make much sense, but that's the definition. It's the mass times the velocity. Yeah, I don't understand it either. That's what it's defined as. If you search it up on Wikipedia, that's what it says, or some other weird thing. So basically, find the conservation of momentum in 2D. Here we have a lovely image of Bill Nye. Really, really nice guy actually. So okay, so we're gonna start easy here. Calculate the momentum of a 1,250 car moving at 15 meters a second. Momentum is mass times velocity. So you get the mass, you multiply by the velocity. Really, really simple. Number two, okay, this seems kind of hard. So a 12,600 kilogram railroad car travels alone along a level frictionless track with a constant speed of 18 meters a second. A 5,350 kilogram load initially arrests its drop onto the car. What will be the railroad car's new speed? To figure this one out, what you do is that this weight right here times this mass times velocity before is the same as the momentum after. So what we're really finding is this mass times what speed equals this mass times that speed. I currently don't have a paper, so I can't show you. However, if I could, I definitely would. So if we were to do the math right here, um, hopefully you can see it right here. So if I was to get 12,600, I multiply that by 18, I get 226,800. I get that number, and then I divide it by 5,350, and that will give me my velocity in meters per second. Velocity in meters per second. That should be right. Those parts and speed. Yeah. So if we keep on doing more questions here. Okay, these questions are kind of annoying in my opinion. 2 kilogram ball is rolling at 2 meters per second to the right along a frictionless surface and bumps into a 4 kilogram ball traveling at 4 meters to the left. So basically they go and they boom, bounce apart. The 2 kilogram ball moves off at 2.5 milliseconds. At what velocity does the 4 kilogram ball move at? So if I go like this, boom, hit it. This ball moves at 2.5 meters per second, and I have no clue what this one moves at. So what I use is I get the total momentum before. So I get these two numbers, multiply them, then plus the other ball, and then that would equal the other momentum as well. And then I just have one variable to work with. If you do the math, you'll figure it out. Can't write right now, so I can't really show you, unfortunately. And you do the same with this one as well. Since it is almost 8, I have to go to sleep soon actually, so I'm gonna hurry up right now. Plus, I was planning on doing this a little bit faster than if this live stream didn't record the audio before. Did the thing freeze maybe? Oh. Never mind. It is up now. So if we keep on going here with all of these elastic collisions, very simple again. Elastic is when there is no friction, nothing, and the kinetic energy is conserved. Inelastic is when it is not conserved. There is basically no such thing as an elastic collision in our world, as there's always air drag and friction. And here's another question. Same thing, the momentum before is the same as the momentum after. So you multiply all of these numbers, and then what you would do is you multiply all of these numbers, find the missing variable, get that number, and then multiply it here. Here it's asking whether the collision below is elastic or inelastic. I don't know because I can't do the math right now. I can't write on this. Kind of wish I could though. Um, so review. Okay, so that's topic one. That is all you need to know for Unit 1. I'm going to grind through Unit 2 extremely quickly right now. Okay. Periodic table, easy. The atomic number is all the number of protons and neutrons. Um, the atomic number is the amount of protons. The atomic mass is the number of protons and neutrons. Um, yeah, all of this stuff. Um, easy. If you get a table like this, I doubt you'll get this because this is very simple stuff. If I get a random number, if you get a random element, you can easily calculate the number of protons, number of neutrons, and the atomic mass by adding up the different components, such as the atomic number, and minusing that by the atomic mass to get the number of neutrons. And basically what an isotope is when someone adds more neutrons to the atom, it creates an isotope. And if I keep on going down, there's 3 different types of radioactivity. There's alpha, beta, gamma. Alpha rays penetrate very little because they're helium atoms, so they're much bigger. Beta rays are high-speed electrons, and gamma rays penetrate through everything because they're just very high-intense light. This is the electromagnetic spectrum. I doubt that's ever going to be asked in this test. So alpha rays can be written as this little alpha sign, or as the helium atom. Same thing with the electrons. You can just write a beta sign or an E and a -1 for neutrons. Basically, this -1 is -1 of proton. So since an electron is negatively charged, it does the opposite of a proton. So if you can look closely here, the number at the bottom, depending on which number is bigger, the smaller number is the amount of protons, the bigger number is the total mass. So if you want to find the neutrons of a specific element, you just minus the proton number by the mass. That will give you the neutrons. Easy, done. Move on to the next question. The thing with these types of exams is that you have to be quick. It's not like the SAT where you have to be really quick, but in these types of exams, if you can just nail the easy ones right away, you'll have more time to contemplate the 7, 8 questions. That's what I do. That's what I suggest you do. But you can do what you want, really. These equations, again, very, very, very simple. The numbers here add up. These numbers up here add up to this number, total mass, and the number of protons adds up to the total number of protons over here, and it's the same in every single equation. That's that stuff. Half-life is the atom starts decaying and starts losing mass. I'm not going to go through this. It's pretty simple. It's always a downward slope. As it starts losing mass, calculating half-life, this stuff. Fission. Fission is when a neutron is sent towards a big uranium atom, for example, and then it breaks apart, releasing energy. And fusion is when you combine two things, you fuse them together, right? Such as the sun, which uses helium to fuse. And the reason why that works so well for the sun is that it has such a big mass, so it can compress those helium atoms together really, really easy because it's just so big. Here on Earth, it's really hard to achieve because you need a lot of heat and a lot of pressure to actually combine these together. And in the process, they do release energy. These questions are very simple again. Okay. So this is probably the hardest part of the entire unit. There's something called one sec. Something called, what was it called? Mass defect. Okay, this is pretty interesting stuff. So when physicists first started experimenting with atoms, atomic masses and stuff like that, they found that the mass they thought of an atom, based on the weight of neutrons and protons, was actually different than the actual mass of the atom. The reason why, this is called the mass defect, which is when physicists thought that the mass would be higher, but it was actually lower. And they figured out that the reason why that happened was when the atom was forming and when the atom was bonding, it took a bunch of energy to actually get the protons and the neutrons into the nucleus and everything going on. If you have enough, sorry, Kyle, I'll go to you in just a second. But what happens here is that you keep on getting them together, it creates mass defect, and the reason why it's called binding energy, and they figured out that this energy was the cause of the mass defect, which meant that energy was actually, sorry, which meant that mass was actually being turned into energy. That's where his famous equation came into play, E equals mc squared. And the way to calculate this is where you get the mass defect, which is the missing mass, and then you just convert that into joules. I'd strongly recommend you put this on your cheat sheet. Very simple, I have it on mine. Don't have my cheat sheet right here with me, but what you basically do is you just get the mass defect, you multiply that into mega electron volts, which is the amount of energy you need, and then once you have that number, you multiply that, even I have to check my cheat sheet sometimes, you know, but write this on your cheat sheet and then you'll know the entire layout. I wrote it on mine, just a little instruction manual on how to do it. There's no point in memorizing this because it's really, really challenging to memorize all the small numbers and mega electron volts and the steps. But if you just write it correctly on your cheat sheet, you should be able to do the hardest questions in this topic. Currently my Wi-Fi is working right now. Cheat. You can tell my computer is pretty slow. So how do your guys' cheat sheets look like? This is how mine looks like right now. The Wi-Fi can load. Okay, Kyle, I'll go to you first. Yo, Joaquin, if you have enough energy, could you go over Unit 1, Lesson 12, Question 2 at some point? Thanks. I would love to. However, my mom is forcing me to eat right now, and I have to go to sleep. If I can do this quick enough, I will go there. So you find the difference in mass, which is measured in units. Then you multiply it by 931.5 mega electron volts, then by 10 to the power of 6, which is a million. And then you convert the electron volts to joule. Yeah, that was the last step that I couldn't remember. It's a very simple conversion. Once you have the electron volts, you multiply by 1.6 to the power of 10 to the negative. Sorry, you multiply 1.6 times 10 to the power of negative 19 joules. That converts it to the amount of energy this atom has. So if we go back here, I have to speed up right now. So that's that stuff. You can figure out all these questions. For example, this one right here. Volume down shows that the minimum energy has to initiate. If I go here to B, the minimum amount of energy a neutron must have to initiate the reaction above is 2.5 electron volts. The mass of lithium is this. The mass of the tritium is this. I don't know if you guys can see this right now, but what it's asking me to do is calculate the mass defect and then prove it that the amount of energy needed is 2.5 mega electron volts. Can't write right now here on this computer, on this TV. I would love to though. That's how you do that. I'm just going really quick right now because the microphone thing slowed us down. So if we go back here, charge and heat conservation. A few simple rules. Okay, so we go here, start state Ohm's law. V equals IR. Voltage equals current times resistance. So what does the formula R equals resistivity length times A mean? Very, very simple. It shows basically how much a resistor can resist current and what are the variables to identify that. That's what resistivity is. And the special R right here is the material that you have. for the resistor. Here are a few currents. Sorry, here are a few circuits where you have to measure stuff. Okay, here is the big point. Electrical current is the flow of charge. So current is measured in amps, and the charge flowing per second is coulombs divided by T. Okay, you might be wondering what the hell is coulombs? It is very simple. It is just a lot of electrons. You can think of it as a bag of electrons or a box of electrons. A coulomb is just a few, I don't even know the number, a few million, probably even billion electrons. So the charge per second is how much of those coulombs are flowing through the wire per second. Very, very, very simple. There's also a bunch of laws that state how currents function. The current in is the same as the current out, as well as parallel circuits, which when you see it, they actually have the same current in parallel circuits. I'll talk about that in just a few minutes. Here's a diagram. Here's some circuits. I have this on my cheat sheet. I'd strongly recommend you put it in as well. It's just a very simple, very simple thing that explains exactly how resistors, how circuits function. For example, if resistors are in series, they add up. That's for resistance. So if I have a series circuit where it's just one wire, right, where the current travels through, they all add up, and resistors in parallel are figured out by a formula, which is 1 over R. Total is equal to 1 over R plus 1 over R plus 1 over R. Voltage is the resistors in series add up. Parallel circuits all have the same voltage, and series resistors experience the same currents. Parallel would not. Write this stuff down on your cheat sheet. It helps so much. So much. Like I won't be able to solve many questions if I don't have this, because it's a very simple guide. Voltages at resistors in series add up to a total voltage. Parallel circuits have the same voltage. Very helpful in solving these very complicated circuit diagrams. So you've got the power. Okay, so there's a difference between watts and joules, or in other words, power and energy. You can think of power of how, let's say I am pushing a box on a road. I don't know why you would do that. If I'm pushing a box, I need quite a lot of power, right? Just move the box, just hit it, just go at it, just push it across. That would be power. How much, I wouldn't say energy, but how much is needed to push that box. Work, on the other hand, is power. I believe it's power divided by time or power times time. I'm not entirely sure. I believe it's power times time, but it's how much time I'm spending pushing the box. If I spend less time pushing the box, it means I did more work, and I put, I guess you could say, more energy into moving this box. Work is energy, calculated in joules. So if I want to calculate the energy of something, I get the watts and I multiply it by times. Again, if I want to find the energy of something, I get the watts, I multiply it by time. This is going to be an exam question. I can guarantee it right now. Okay, that's this stuff. Very simple questions. Go to the sheet I sent you guys. Fill that out. Do these questions now that you know power of watts. I added a really hard one actually. Somewhere here. I don't even know where it is, but there's one extremely hard, and if you just know that the energy is watts times time, you'll be able to solve these hard questions really simple. Okay, we look here. Okay, so now we move from circuits into heat. Kelvin is basically absolute heat. Kelvin, 0 Kelvin is something called, what's the name? I think it was absolute temperature. Anyways, 0 Kelvin is where atoms stop vibrating altogether. They lost all of their energy and they have none. So that's what 0 Kelvin is and why it's used, because you can see how far you are from that 0 point. Yeah, it's called absolute zero, now I remember. So some of these, simply um, calculating the difference, very, very simple. You just get 273 because that's where absolute zero is. And then you plus or minus the Celsius. For example, if I was to calculate the Kelvin temperature of negative 20 Celsius, I'd get I get 273, and I would minus that by 20. Easy. Very, very easy. Okay, so these are different forms of conducting energy. Convection is if I touch something, the energy from my hand goes onto the thing I touched. Conduction, sorry, conduction, apologies. Conduction is when I touch something and hot goes from my hand onto the thing I touch. Convection is when warmer air, because it is, when colder air, because it is less dense, goes up, warmer air takes the place. So it makes this convection current. That is mainly prominent in hurricanes and is the answer to the question on the review sheet if you read the email. So this is the most important part of this unit. It's called specific heat capacity. Again, if you understand it, it's really, really simple. Q is joules, M is mass, let me open this up, and C is something you've probably never seen before. It is called the specific heat capacity. It is how much energy is needed to heat up 1 kilogram by 1 Celsius. So if I had something like a brick, it would have a much higher heat capacity. It would be able to heat up much faster than something that is less conductive, such as glass. So that is why we use heat capacity to measure wires and how conductive they are. Then change in temperature, delta T, that is the initial temperature minus the final, or the other way around. The initial minus the final, that creates the change in energy. And that's the equation. Very simple. Easy, simple, fast. Okay, when it comes to one object, if I just want to find the heat capacity of one object, you just plug it in. If I want to find the heat capacity of 2 objects, which is probably the most important thing here and the hardest thing, I get one object here equals the other object. For example, that probably made no sense. If I add a burning hot piece of aluminum into water, what's going to happen is that the hot thing is going to go to the cooler water. So I'd add the heat capacity, or the energy needed to heat that up. I'd add it on the left side, and since energy is always conserved in this course, I'd add the water on the right side. So then I just plug in the values, and whatever value I'm looking for, whether it be final temperature, the only thing you have to do is just some algebra, simple multiplication, move a few terms over. Very, very simple stuff. And if this is the interesting stuff. If I'm putting 3 things into the equation, you might be asking, okay, so where does one thing go on which side of the equation, right? So for example, if I'm putting lead and aluminum into cool water, what's happening here is that I'm putting 2 substances into one thing, which will mean that the energy in both substances is being transferred into the cooler thing. So what would happen here is that I'd get both of these substances, I'd put them on one side of the equation, and then on the other side of the equation, I would have that cool water. And then the only thing you have to do up there is just plug in the terms and then find out the missing variable that you're trying to find. That's basically it. That's all you need to know. One thing I would like to say though about this specific heat capacity is that if it ever asks you for the final temperature, what you're going to find is that each equation is going to have, each joules, each specific heat capacity is going to have one temperature that is an unknown. And since change in T is the initial temperature minus the final temperature, that initial temperature will be the unknown. So what will happen here is that you'll have 2 unknowns on the equation based on how many objects you have. Hopefully that makes sense. That'll help you solve one of the really hard questions that I added onto the review thing, the review sheet. You should definitely go there. I have to go and eat right now and then go to sleep, so I'm gonna answer Kyle's questions. Kyle's question really quick right now. So unit 1, question 2. Let's go. So unit 1, lesson 12. Oops, wrong thing. Unit 3, topic 2. Sorry, where am I right here? Unit 3, outline notes. Oh, the hell? Okay, I actually have to open this one up, man. One sec. Yeah. Anyways, do you guys have any questions? Right now is the time. I won't be going through the questions I added in my document because I have to go right now. But hopefully that helps you as it helped me. Okay, question 2. Okay, lesson 1. Sorry, unit 1, lesson 12. Question 2. So drop into roll, blah to be. This one seems a little tricky. What I would do though is that, again, the momentum before is the same as the momentum after. The only thing that changes here is that the object gets, the only thing that changes here is that the object, the railroad car, gets heavier, which then causes the momentum to change. So, Kyle, if you're listening, what you would do is you'd get mass times velocity. So you get this number right here, 14,600 kilograms. Multiply that by 18 meters per second. That would give me 12,000. I don't think you guys saw that. My phone kind of did a little glitch, so I'll start again. So if I get a 12,600 kilogram railroad car, it's going at 18 meters per second. Please watch this, Kyle. It'll help you a lot. I got 12,600 kilograms. Then I multiply this by 18. It would equal this number, so 226,800. So now that I have that number, what I would do is I get 5,350. I would add this number to the original weight of the railroad car. So that would be 5,350 plus 12,600, which is 17,980. Sorry, I need to get some paper, else I'm gonna forget this. One sec. Okay, I couldn't find paper around. Found this book, so let's write in it. It's a textbook, by the way. Is it? Okay. So if I get the momentum before, crap, it's out of lead. So I get the momentum before, it would equal the momentum after. Equal the momentum after, which is NV equals
mv, so mass times velocity. So I know the mass before, which is 12,600. I then multiply that by 18 meters per second, and that would equal 17,000. On the other side of the equation, 17,950 kilograms, because if I get this number right here and I add it by the original railroad car, that would give me 17,950. I'd multiply that by the velocity, which I don't know. So just be that, which would then equal, I get this number, sorry, 12,600 times 18, that would equal 226,800. I'd multiply this number, sorry, I'd divide this number by the weight of the railroad car, which is 17,000. So it would be 17,950. That would equal 12 meters per second. So the velocity would end up being 12.635 meters per second. I hope you understood that, Kyle. Please tell me you did in the comments. That way my ego can be satisfied. And if you have any questions, you can send me an email. Please finish working on the review doc. Do it today, and then you'll be prepared for the exam tomorrow. I hope this helped you. It definitely helps me, because the best way to learn something is by teaching it to people, and I had to learn this myself. I read through this entire thing, did a bunch of questions. I even made my questions, and that helps you learn the concepts yourself. So I am definitely ready for this. Let me know if you guys are ready. If you have any questions, again, just tell me. I read them right here. Other than that, I have to go and eat. I hope you have an amazing day. I want to leave you with one more proof of thought, so to say. The most important aspect to doing good on a test the day before is not studying. They actually did this study. They found that people who spent their night studying performed worse than those who spent their night sleeping. The most important thing before the test begins, is sleep. So this hopefully helped you. Do the questions and then stop studying. It's just going to have a detrimental effect on you. You probably should have studied. You probably should have started studying a few weeks ago, as I did. It really helps you accumulate that knowledge. So, go to sleep. I'm going to sleep in around 20 minutes. I'm going to eat. I'm just going to head up. I'm also pretty jet lagged, so kind of tired. And other than that, I hope you have a productive day and a productive week. Stay productive. I'll see you guys tomorrow.